Hello students, today we are going to start with our syllabus of class 9. We are going to start with our first chapter of the syllabus, that is number system. We already have studied the different type of the numbers in earlier classes. Today we are going to revise all those different kind of numbers once again. So first of all, we'll see the types of numbers which we have studied. First, natural numbers. We know that the natural numbers are denoted by capital N, and the numbers 1, 2, 3 and so on are called as natural numbers, which were initially used for the counting purpose. Next one, the second list of numbers is whole numbers, which is denoted by capital W. When 0 is added to the list of natural numbers, it becomes a list of whole numbers. The numbers 0, 1, 2, 3 and so on are called as whole numbers. The third type of numbers which we already have studied are nothing but integers. The integers are denoted by capital I or capital Z. Integers are the set of numbers which includes 0, natural numbers and negatives of all the natural numbers. The numbers from minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on are called as integers. Actually, we have seen there are two different capital letters which are used to denote an integer, that is nothing but I or capital Z. I can be understood for integers, but Z has come from a German word zählen, which means to count. So this is all about first three type of the numbers. Let us discuss the fourth type of the numbers, that is nothing but rational numbers. Let us start with the fourth type of the numbers, that is nothing but rational numbers, which are denoted by letter capital Q. Rational numbers are the numbers which can be written in the form a upon b, where a and b both are integers and denominator b should not be equal to 0. Means rational numbers are nothing but fractions which can be written in the form a upon b. Getting it? Only important thing here is numerator as well as denominator both should be integers and no other kind of numbers, and denominator should be non-zero. Numerator can be 0 but denominator should be strictly non-zero. Let us see some examples of rational numbers. First one, 3 upon 7. Here 3 as well as 7, both the numbers are integers. That's why 3 upon 7 is a rational number. Minus 5 upon 4. Minus 5 as well as 4, both the numbers are integers. That's why minus 5 upon 4 is also a rational number. Very important thing is, in both these examples, denominator is non-zero, which is very important condition for being a rational number. Next number is 6. We know that 6 is a natural number, a whole number, as well as an integer. Now we know that 6 can be also written as division of two numbers, like 6 upon 1, like 12 upon 2, 18 upon 3, 24 upon 4 and so on. By using many different ways we can write this 6. So in short, 6 can be written as 6 can be written in the form of a rational number, that is a upon b. That's why 6 is also a rational number. In short, we can say that every natural number, every whole number, as well as every integer is a rational number, as we can write those numbers in the form of a rational number, that is a upon b, where denominator is non-zero. Let us go to the next number, that is 0. 0 is a whole number as well as an integer, but 0 can be written like 0 upon 2, 0 upon 13, 0 upon 905, 0 upon any non-zero integer. Getting it? So this also satisfies the definition of a rational number where denominator is non-zero. Remember that there is no condition on the numerator. Numerator can be 0 provided that denominator is non-zero. And very important note is 0 upon 0 is not 0. It is undefined, indeterminate form that you will learn in the higher classes. Our next example is 0.76, which is nothing but 76 upon 100. We know that 0.76 can be written in the form 76 upon 100. So it is also written in the form P upon Q in the form of a rational number. That's why all the decimals which are terminating are rational numbers. Next example, minus 1.3 recurring. This can be written as minus 4 upon 3. We know that if we divide minus 4 by 3, we will get quotient as minus 1.3333 and so on. So minus 1.3 is recurring, that's why we can write minus 1.3 bar. So minus 4 upon 3 is also a rational number. Getting it? So in this way we can give many examples of the rational numbers. These are the some of them. You can take division of any two integers and that is your rational number. Only care you have to take is denominator should be non-zero. Now let us discuss some more terms about rational numbers. The first one, the word rational came from the word ratio. Ratio is nothing but division of two numbers. In the rational numbers, we are actually taking division of two numbers, that is a upon b. Now next one, the letter q, which we are using to denote the set of rational numbers, has come from the word quotient, which is nothing but division. Next note, we already have discussed this one. All natural numbers, whole numbers and integers are rational numbers as they can be expressed in the form a upon b. We know that, we have seen this, we have seen the example of 6, 0, they can be expressed in the form of a rational number. Now next note, all rational numbers need not to be natural, whole numbers or integers. See, one thing is very clear, all natural numbers, whole numbers and integers are rational numbers, but all rational numbers need not to be a natural number, a whole number or an integer. For example, see 15 upon 8. 15 upon 8 is a rational number, but it is not natural or integer. Similarly, minus 3 upon 5. In fact, like our natural numbers, whole numbers and integers, there are infinitely many rational numbers too. So this is all about rational numbers. Now we are going to discuss the next type of numbers, that is nothing but the next type of numbers which we are going to discuss is irrational numbers. Irrational numbers are the numbers which cannot be written in the form a upon b, where a and b are integers and b is not equal to 0. This is the definition. In fact, we can say that the numbers which cannot be written in the form of a fraction are called as irrational numbers. Some people are defining irrational numbers like the numbers which are not rational are irrational, which is not at all true. Why? Because see, in rational numbers we cannot take denominator as 0. So for example, if we take 4 upon 0 is not a rational number, correct? Because we cannot take 0 as a denominator. Means if you are using the definition that the numbers which are not rational are irrational, 4 upon 0 is not rational. So does it mean that it is irrational? No. So the definition that the numbers which are not rational are irrational is completely wrong. we have to define irrational numbers like the numbers which cannot be expressed in the form a upon b are irrational numbers, where a and b are integers and denominator b should not be equal to 0. Or we can say that the numbers which cannot be written in the form of a fraction are irrational numbers. Let us see some more things about irrational numbers. If we write irrational numbers as decimals, we can say that irrational numbers have non-terminating and non-repeating decimal expansion. So irrational numbers are non-terminating and non-repeating decimals. Definitely no irrational number can be written in the form of a fraction. So they are simply decimals which are non-terminating and non-repeating. The next thing, in irrational numbers, no particular number or a group of number repeats. Like we have seen, if in the decimal expansion of a number, if a particular number is repeating or a particular group of number is repeating, that number is a rational number. We will study more about that in a further part of this chapter. But till now, you have to remember that in irrational number, no such particular number or a group of number repeats. Wherever a particular number or a group of numbers is repeating, such kind of numbers are called as rational numbers. The next part, we will see some examples of irrational numbers. The first one, 0.123256159. In this decimal number, we can see that no particular number is repeating or not a particular group of numbers is repeating. There is not a particular pattern in the decimals in the order in which they are occurring. So this number is irrational because these three dots are representing that this is not terminating. So these three dots are very important. If you are not giving these dots and only writing 0.123256159, it means it is terminating at 9. So it will be a rational number in that case. So to indicate an irrational number, you have to write three dots in the end, so that it will mean that it is not terminating. Getting it? For the second example, 45.86745893. Here also in the decimal part, we can see that not a particular number or group of numbers is repeating. The next one is pi. We know that pi is the ratio of circumference of a circle to its diameter, and that value approximately comes 3.14159 and so on, where no particular number or a group of numbers is repeating. That's why pi is also an irrational number. The value 22 upon 7, which we take for calculations, is approximate value of pi. It is not the exact value. So it should not be the that misconception should not be there that pi is 22 upon 7 and it is a rational number. The actual value of pi is 3.14159, which is an irrational number. We also have one more number like pi, that is e. You will study about this also in higher classes. It is logarithmic constant, which is given by 2.7183 and so on. This is also an irrational number. The next one is square root 2. Square root 2, we know that we can find the value of this number by using long division method, which we have studied in class 8. So if we find the value of square root 2 by using long division method, we will get it is equal to 1.4142135624 and so on. And here we see that not a particular number or a group of numbers is repeating. That's why square root 2 is also an irrational number. In fact, a number which is not a perfect square, if you take square root of that number will be always an irrational number. So square root of a non-perfect square number is always an irrational number. For example, square root 3, square root 5, square root 7, square root 8, square root 6 also, square root 10, all these numbers are irrational numbers. we are again going to study how can we represent these numbers on the number line in the next class. But the numbers like square root 1, square root 4, square root 9, square root 16, which are the square roots of perfect squares, these numbers are rational numbers because we can find their square roots. Similarly, we can say that if we take cube roots of non-perfect cube numbers, those numbers are also irrational numbers, like cube root of 2, cube root of 3, cube root of 4, cube root of 5. All these are the examples of the irrational numbers. In short, we can say that if we cannot get answer of some root, some surd as a rational number or or an integer, that number is irrational number. So this is all about irrational numbers. In next, some more things about rational numbers and irrational numbers. We are going to write these things in notes. The first one, there are uncountable, that is infinitely many rational numbers as well as irrational numbers between given two rational numbers. Suppose we have given any two rational numbers. Okay, we cannot say that these two rational numbers are consecutive. For example, suppose we have given 1 upon 2 and 1 upon 3 and 2 upon 3. You cannot say that these are consecutive numbers. We can still find infinitely many rational numbers or infinitely many irrational numbers between 1 upon 3 and 2 upon 3. So there are uncountable rational numbers between given two rational numbers. This is the first note. We will see the explanation of this one. See, suppose we have two rational numbers, 1 upon 4 and 2 upon 4. Now 1 upon 4 can be written as 0.25, where 2 upon 4 can be written as 0.50 or 0.5. Now between 0.25 and 0.50 there are infinitely many rational numbers like 0.26, which can be written as 26 upon 100, 0.27, 0.28, 0.29 and many more. Even if I am saying 0.264, that is also a rational number. It can be written as 264 upon 1000. Getting it? So there are uncountable rational numbers between given two rational numbers. Let us discuss this further for irrational numbers. See, we have numbers 0.25 and 0.50. If you want to write irrational numbers between these two, let us take some examples like 0.2612546. Clearly you can see that it is an irrational number because no particular pattern of numbers is repeating there. Getting it? Next one, 0.4325164 and so on. Getting it? Like these numbers we can write as irrational numbers between given two, and we can write infinitely many numbers. You just see the first two digits, 0.25 and 0.50. These are the numbers and we want to write the numbers between these two. Getting it? So to write the numbers between these two, we have many options. Only we will write the numbers between 25 and 49, and anything can be written after that. Suppose I am taking number 28, 0.28. After that you can write your mobile number also, whatever you want to write. But we can write infinitely many irrational as well as rational numbers between given two rational numbers. Yes, the second note we will see, there are uncountable, that is infinitely many irrational numbers between given two rational numbers. We just have seen this between given two irrational numbers. Like we have seen that there are uncountable rational numbers or irrational numbers between two rational numbers. In the same way, we can also say that there are uncountable irrational numbers or rational numbers between two irrational numbers also. For this, let us see this one. Suppose we have given two irrational numbers like 0.2313152 and so on, and second one 0.242525 and so on. Suppose these two are the irrational numbers, so we can write the numbers like 0.23. See, we have numbers like starting with 23 and 24. Okay, 2, 3 and 2, 4. So just see the third number is 1. We can write any number, but starting should be with 2, 3 only, 2, 3 or 2, 4. But that number should be between given two numbers, and the numbers like 0.2352 6534 and so on, or the second number which we have written is 0.240124642 and so on. These numbers are lying between given to irrational numbers. So like this we can write infinitely many irrational numbers between given to. About rational numbers, just remove that and so on part, and suppose for example these two numbers are given. I can write 0.2313153 terminating at 3 is a rational number. So in this way you can write infinitely many rational numbers between given two numbers. Now let's discuss the next part. We are actually going to start with the problems. The first question here is to write any four rational numbers between 1 upon 3 and 2 upon 3. Just now we have seen the note that there are uncountable rational numbers between any two given rational numbers. We have given 1 upon 3 and 2 upon 3, and we are supposed to write four rational numbers between them. Let us see how to solve such kind of question. Answer of this one. The first of all, we will consider the given rational numbers, that is 1 upon 3 and 2 upon 3. See, whenever they are asking you to write some particular number of rational numbers between given to rational, particular number of rational numbers between given numbers, see, they are asking you to write four rational numbers. If they are asking you to write four rational numbers, add 1 to it, so we will get 5. Now, you can multiply by 5 to numerator as well as denominator of both the given fractions, so that you will be able to write four rational numbers between them. Okay, minimum number which should be multiplied to both the numbers which are given to us to their numerator also as well as denominator is one more than required number of rational numbers. Here in this question they have asked us to write four rational numbers between given two numbers. So minimum number by which we should multiply both the numbers, their numerator as well as denominator, is 5. You can take any other number, but it should be 5 or greater than 5, and it should be a natural number or whole number, you can say, or an integer maybe if it is negative number. See, so here first of all we will write 1 upon 3. We are going to make it very simple. Rather than multiplying it by 5, we will take any bigger number than that. The number for the calculation is 10, so we are going to multiply numerator as well as denominator of 1 upon 3 as well as 2 upon 3 by 10. So if you multiply by 10, see, 1 multiply by 10 in the numerator, 3 multiply by 10 in the denominator, so the same fraction can be written as 10 upon 30, and the second fraction is given to us as 2 upon 3, so this number can be written as, by multiplying numerator and denominator by 10, as 20 upon 30. So we have got two more rational numbers which are 10 upon 30 and 20 upon 30. Now we are supposed to write any four rational numbers between these. See, now 10 upon 30 is the equivalent fraction of 1 upon 3. 20 upon 30 is equivalent fraction of 2 upon 3. See, so we are writing any four rational numbers between 1 upon 3 and 2 upon 3. That is nothing but 10 upon 30 and 20 upon 30. So we can write the numbers like 11 upon 30, 12 upon 30, 13 upon 30, 14 upon 30, and so on up to 19 upon 30. We can write 9 more rational numbers, but they are asked only 4, so these are the 4. Getting it? So this is the way of writing the required number of rational numbers between given two rational numbers. So this is the first question. The next question we will see again of the same type. The question is to write 5 rational numbers between 4 and 5. So first of all, what we are going to do, the 4 and 5 are the integers. We are going to write them in the form of a fraction, in the form of a rational number. So simply we can write 4 as 4 upon 1, 5 as 5 upon 1. So see, we will consider the given rational numbers. 4 can be written as 4 upon 1, 5 can be written as 5 upon 1. We know that it can be that 4 can be also written like 8 upon 2 or any other numbers, but we will make it very simple. We will keep it simple. 4 can be written as 4 upon 1, 5 can be written as 5 upon 1. Next part, see, 4 upon 1. Now again we are interested to write 5 rational numbers between 4 and 5. So we have to multiply by a number 5 plus 1, 6 or more than 6. Okay, as we have decided for sake of simplicity, we are going to always multiply by 10. So it will be easy for us to calculate. So 4 upon 1, we will multiply numerator and denominator by 10. We will get equivalent fraction of 4 upon 1 as 40 upon 10, which is nothing but 4 only. And 5 upon 1, similarly will multiply numerator and denominator by 10. We'll get that is equal to 50 upon 10, which is nothing but 5 only. So now we are supposed to write 5 rational numbers between these two. So the 5 rational numbers between 4 and 5, actually it should be 5, 41 upon 10, 42 upon 10, 43 upon 10, 44 upon 10, 45 upon 10. Like this you can write up to 49 upon 10. Even if you want, you can multiply by some bigger number also. You can multiply by 100. No issue. Getting it? But that number should be greater than or equal to 6, because they are asking us to write 5 rational numbers. So whatever number we are going to take should be greater than or equal to 6. One more than total number of required numbers they have asked. Next question, the third question they have asked is to write any 5 irrational numbers between 1 upon 2 and 2 upon 3. So now the question is to write irrational numbers, and we know that irrational numbers can be written in the form of decimals only. So our first job is to convert given two numbers in the decimal form. So we will write 1 upon 2 and 2 upon 3 in the decimal form by using long division. So we will start our answer. We know that if you want to write 1 upon 2 in the decimal form, it can be written as 0.5 or 0.500 I have written. And the second number 2 upon 3 can be written as 0.666 repeating, and so on. So these are the two numbers which are written in the decimal form. Okay, now we are supposed to write 5 irrational numbers between 1 upon 2 and 2 upon 3, that is 0.500 and 0.666. So we can write the numbers like, first one we have written, okay, just take care of the first two numbers or first three numbers, we'll say. First, if you consider first two numbers, then they are 50 and 66. So you start with any number between 50 and 66. See, first number we have started with 51. So 0.51. After that you can write whatever you want to write, but just take care that no particular pattern of numbers or a particular number should be repeating. So we have written 0.512, 513, 514. Any numbers you can write, but just take care that beginning should be between the first two digits. You have to see it carefully. The second number which we have written, we have started with 53, which is between 50 and 66. Getting it? So 0.534, 535, 536. The third number we have started with 56. Then we have written 0.567, 568, 569. Whatever you want to write. Similarly, remaining two numbers are also written. Fourth number is started with 57. We have written 0.575, 859, whatever the pattern you want. Actually, it is 57, 58, 59, 60, 61, 62. Consecutively, like these numbers you can write. It is very simple to write the irrational numbers between given two numbers. The fifth one, we have started with 62, which is again a number between 50 and 66. So the fifth number we have written starting with 62, 0.629, 524, 67. Anyhow it is written. Whatever you want to write, you can write there. Just take the first two or three digits. You have to see that very carefully. Now let us start with the fourth question. The fourth question is write any 5 rational numbers between 2 upon 3 and 3 upon 4. We already have seen the questions of this type, but a bit change is there in this question. In the previous questions which we have studied for writing the rational numbers between given two rational numbers, the denominators of the given two numbers were same. So it was very simple for us. Simply multiply by 10 or any number which is greater than total number of required numbers. We were taking to multiply numerator and denominator. But here you can see that the denominators of both the numbers are different. So our first job is to make their denominators same and then multiply by 10. Getting it? Actually we can multiply by any number which is greater than 5. So we can start with 6. 5 plus 1, 6. So first of all, we'll make equal denominators, and then we can multiply by any number which is greater than or equal to 6 to numerator as well as denominator of both the fractions. But as we have decided, for sake of simplicity, we are going to multiply both the numbers, their numerators and denominators, by 10. So let us start with the answer of this one. First of all, let us consider the first both the rational numbers, that is 2 upon 3 and 3 upon 4. Now, to make the equal denominators, we have a technique. What are we going to do? To make the equal denominator, suppose we are taking 2 upon 3. Okay, so we will multiply this fraction by the denominator of the second fraction, which is 4. So first of all, we'll multiply by 4 to both the numerator and denominator, and then we will multiply by 10. Similarly, when we'll come to the second fraction, that is 3 upon 4, here we will multiply numerator as well as denominator by the denominator of the previous fraction, which is 3. So this thing you have to remember, and then we are going to multiply by 10. Okay, so remember this. How are we going to make equal denominators of both the fractions? So first thing, we will multiply by denominator of the second fraction to the first fraction, numerator as well as denominator. And second thing, we will multiply numerator and denominator of the second fraction by denominator of the first fraction. Getting it? And then we will multiply by 10 or whatever number you want to, which is greater than 5. Okay, because we want 5 rational numbers. See, so 2 upon 3, first of all it is multiplied by 4, numerator as well as denominator, which is 4. Why 4? Because 4 is denominator of the second fraction which is given to us. And then we will multiply by 10. Okay, because we want to write 5 rational numbers, you can multiply by any number which is greater than or equal to 6. So doing this calculation, we'll get equivalent fraction of 2 upon 3 as 80 upon 120. Similarly, we'll come to the second fraction, 3 upon 4. So this 3 upon 4 we are going to multiply by 3. Why by 3? Because 3 is the denominator of the previous fraction, first fraction, 2 upon 3. Okay, why are we doing this? To make the denominators equal. Okay, then we will multiply by 10 to both the numerator as well as denominator. Doing these calculations, the equivalent fraction of 3 upon 4 is 90 upon 120. So here clearly you can see two different rational numbers. We have written the equivalent fractions of 2 upon 3 and 3 upon 4, which are 80 upon 120 and 90 upon 120 respectively. As we have written this, now it will be very easy for us to write 5 rational numbers between 80 upon 120 and 90 upon 120. So we can easily write any 5 rational numbers between 2 upon 3 and 3 upon 4 are 81 upon 100, 120, 82 upon 120, 83 upon 120, 84 upon 120, 85 upon 120, and so on. So this is very easy to write 5 rational numbers between given two numbers. Understood? This is very easy to do. This is a typical question where denominators will not be equal. If denominators are not equal, first of all we have to make them equal. We have seen the method to do that, and then we will multiply by required number. That is, we have always doing it 10. But see, sometimes they may ask you to write 10 rational numbers between given two. At that time you should not multiply by 10. Getting it? You should multiply by a number which is greater than 10. So you can start with 11, and after that there is no limit. You can take whatever number you want to take, but it should be greater than or equal to 11. When if they are asking you to write 10 rational numbers between given two rational numbers. Getting it? Now let us start with the next question. Our next question is to write any 5 irrational numbers between 3 upon 2 and 8 upon 5. Already we have seen how to do such kind of question. So first of all, what we will do, we are going to write given numbers as a decimal number. Both the numbers we are going to write in the decimal form first, and after writing them in the decimal form, we are going to write irrational numbers between them. Let us start with answer. So first of all, 3 upon 2 we are going to write in the decimal form by using long division. If we do 3 upon 2, we can get 1.5. We can write 1.500. And similarly, when we convert 8 upon 5 in the decimal form by using long division, that can be written as 1.6. Okay, or we can write 1.600. There is no value for these zeros. Getting it? So we have got two numbers, 1.5 and 1.6, and we are supposed to write 5 irrational numbers. You have to read question very carefully. Sometimes they may ask you to write rational number, sometimes they may ask you to write irrational number. Okay, so to write irrational numbers between these two, what are we going to do? Simply we have to observe the first number. See, our first three numbers are 500 and here 600. So you can start with the first three numbers between 500 and 600. Any number you can take, whichever you want. Or if you want to give a bit, if you want to shorten this a bit, you can consider only first two digits, that is 50 and 60, 50 and 60. Okay, so you can start with any number between 50 and 60. First number which we have written is 1.51. We have started with 51. After that, whatever you want to write, you can write, but it should not be a repeating pattern. Second number we have started with 53, which is between 50 and 60. Okay, or you consider first three numbers 500, 600. Only first three digits you write between 500 and 600. Any number you can write between 500 and 600. After that, whatever you want to write, you can write. Only thing is that there should be no repetition of a particular pattern. Getting it? So we have started with 512, then 513, 514. We have started with 534, 535, 536. Then we have started with 567, which is between 500 and 600. Then whatever you want to write, you can write. After that, 575 we have started with. After that, you can write any numbers. Then in the end, we have started with 591, and then the particular whatever number of the one numbers you can write or you want to write, you can write. The last possible number which we can take here is 1.599, and after that you can write whatever. But remember that you cannot write 1.5999999 because there will be repetition of 9 there, which is not an irrational number because the group of numbers 9 is repeating continuously. Okay, in 1.59999 like that. Okay, so last number you can take is 599, but after that you write the numbers in different order. Okay, so this is the end of this answer. Next one, let us see question number 6. The question number 6 is to write the decimal expansions of the numbers 10 upon 3, 7 upon 8 and 1 upon 7, and we have to also write the type of decimal expansion of the given rational numbers. We will see how to solve this. This is very simple. First of all, what are we going to do is we are going to write the given numbers in the decimal forms, that is asked in the first part of the question, which can be done simply by using long division. You can definitely do that, but I will still show you how it can be done. It is already done. There is no need of much explanation. Simply it is long division. You can see it. Okay, so 10 upon 3 is given to us. We can divide 10 by 3 and we can see the remainders which we are obtaining, and we will get this number like 3.333, and it is repeating. Recurring means repeating after 3. So there is a repetition of 3 continuously. There is repetition of 3 continuously. So when we divide 10 by 3, you will get answer as 3.333. Here you can see that a particular number 3 is continuously repeating. The second one which we have given is 7 upon 8. When we will divide 7 by 8, we will get answer as 0.875, and in the end remainder is 0. If your remainder in such kind of divisions is coming 0, means your decimal is terminating there, ending there. Terminating means ending. Okay, but if your remainder is not coming 0, means that particular number is continuously repeating. The next one which is given to us is 1 upon 7. This we have calculated up to 6 digits. And see, in the beginning we have 1, and after doing the divisions continuously we have divided, and once again we have got the remainder 1. Means after this again the same group of numbers 1, 4, 2, 8, 5, 7 is going to repeat. Now, the second part of this question, they have asked us to write the type of the decimal expansion. Now, remember that there are only three types of the decimal expansions of a number. Okay, first one is terminating a number can have terminating decimal expansion. A number can have terminating, non-terminating, repeating decimal expansion, that is non-terminating, recurring, and the third decimal expansion is non-terminating, non-recurring, but which is the decimal expansion of an irrational number. The numbers which are given to us are rational numbers. Rational numbers have only two types of decimal expansions, that is terminating decimal expansion or non-terminating repeating decimal expansion. In non-terminating repeating decimal expansion, a number or group of numbers is repeating. Like in the first, we can see that 3 is continuously repeating, a number is repeating continuously. And in the third example, that is 1 upon 7, you can see that 1, 4, 2, 8, 5, 7, a group of 6 numbers is repeating continuously. Now let us write about their decimal expansions. The first one, in first example, the decimal expansion of 10 upon 3 is 3.333, that is nothing but 3.3 recurring. Thus we can say that the rational number 10 upon 3 has non-terminating means non-ending, non-terminating recurring decimal expansion. Recurring means repeating, getting it? So this is not going to end anywhere because denominator is not going to come 0. If denominator is coming 0, then only we can say that it is terminating or ending somewhere. But if we keep on doing this 10 upon 3, you will always get 3 as a quotient and 1 as continuously remainder. So nowhere we are going to get remainder as 0. So we can say that this is repeating. Repeating means recurring, reoccurring. That is recurring. Okay, so 10 upon 3 has non-terminating means non-ending and repeating decimal expansion. Non-terminating recurring decimal expansion. Next, in the second example, the decimal expansion of 7 upon 8 is 0.875. As remainder has come 0 somewhere, we can say that it is having a terminating decimal expansion. So we can say 7 upon 8 has a terminating decimal expansion. Getting it? This is the second type of the decimal expansion. And third one, in the third example, the decimal expansion of 1 upon 7 we have got is 0.142857 and so on. Here, a group of numbers 142857 is going to repeat continuously. So we can write this number as 0.142857 recurring. The group of numbers 142857 is recurring. So this number 1 upon 7 has non-terminating recurring decimal expansion. Getting it? It has non-terminating and recurring decimal expansion. Why? What is recurring here? A group of numbers 142857 is recurring. So a rational number has only two types of decimal expansions. One, terminating, and second, non-terminating recurring decimal expansion. So remember this. This is all for today. The introduction of this chapter. In this video or in this class, we have completed almost 2 exercises of the first chapter, that is number system. You some questions for homework. You have to complete all these questions for homework till tomorrow. You can easily do it. Some questions are given for true and false to check your understanding. All these questions are very easy to do. You can solve this. If you have any doubts in this, you can ask me on the group or on the Google Classroom also. All the best for solving the homework. Soon we will have the second class on this chapter, where we are going to see how to represent an irrational number on the number line. All the best. Thank you.